Okay, good morning everyone. Welcome to today's Open IoT webinar. Just some house rules. If we can get everyone to please turn off their cameras and mics. If you have any questions, please log them in the chat window and we'll attend as many of these as we can at the end of the presentation. We'll follow up with any other outstanding questions after the session. Today's topic is focusing on quick wins for Industry 4.0. The presenter we have for today is Max Jarmatz, Managing Director of NORD Drivesystems. Max will be discussing predictive maintenance and condition monitoring in Industry 4.0 and how to get these quick wins. We'll now move on. Welcome, Max.
I hope you can hear me now.
Yep.
Good morning, everybody. Welcome to our first web session. Last year, we had the favorable situation that we could tour all Australia and had live sessions with an audience. Today is a bit lonely here in my office, but at least I can be without a mask since I'm all by myself. Thank you for joining our session. And I'm now starting with the presentation. 1 second. So the topic today is quick wins for Industry 4.0, the implementation and why we should implement now. And I'm starting off with quickly introducing our company. So NORD is part of the IIOT group, and we are a group of a couple of companies who joined together and join forces to explain our Australian customers how to use the smarts in our devices, how to combine them, and how to support Australia to implement Industry 4.0 into their applications and into their machineries. Starting off, so traditionally, Industry 3.0 consists of a traditional automation pyramid. That means you have a hierarchical system, starting with the field. NORD as a supplier of components of gearboxes, motors, and inverters would be part of this field component. Then the next hierarchy would be the SPS, for example, Beckhoff, supplying the PLCs, then followed by HMIs, visual devices, where you can monitor your controls, followed by a MES system, and on top you have a traditional ERP system like SAP. And within these layers, you would only have communication between adjacent layers. And traditionally, especially in the field, these components were not necessarily smart or not controlled by algorithms. And recently, with the introduction of Industry 4.0, this is changing rapidly. So now almost every device already has a microchip integrated, has storage, and has the capacity to share and process information. And so the next generation of system is then an automation network, also called a cyber physical system. So what are cyber physical systems? A cyber physical system is a distributed decentralized system. Decentralized means, if I go back from the classical pyramid, we are now a network, which is consists of a flexible combination of control systems, actuators, sensors, PLCs, protocols, and they all can communicate with each other, and you don't have a concrete hierarchy anymore. So that means data can be transferred and communicated between all levels, independent of make and model, independent of location, and everything is ruled by algorithms. So that means now even in a actuator like a frequency inverter or in a sensor, you have smarts, you have algorithms that can control the device and generate or take automated decisions. And scientists also divide into autonomous cyber-physical systems. That means the systems which are completely without human interaction, and closed-loop human-machine systems. So whereas defense is more focusing on autonomous cyber-physical systems like unmanned drones or unmanned tanks, whatever, we as an industry supplier, we focus more on the closed-loop human-machine systems. That means we focus on machines that can work autonomously, but whenever the humans need to interact, they cannot interact. So that's basically the future of machine building. So from an actuator level, what is NORD doing? So we can communicate relevant data from the field level to a central PLC or to an upper system in the hierarchy. We can locally process drive data and take independent decisions within the drive. And this allows the customer for a modular design of the system. So that means the customer can now decide if they want to use the processing power already in an actuator and define algorithms. And I will come later with examples what we have implemented already. Or if they just want to communicate that data to a PLC or to a higher unit and process the data there. So that means you can define independent structures, independent clusters, and don't have to collect all the data on a higher level and process it there, or where it's more complex and where you have to deal with more data. So what's the advantage for the customer there? So currently we can use condition monitoring. That means the drive, in our case, monitors itself to avoid impermissible operation states. What we are monitoring is thresholds. So basically we define critical thresholds, and the drive would give a warning when this condition is reached. We also offer predictive maintenance. That means the status of the drive is continuously monitored, and then based on the condition of the drive, a maintenance warning is given to the operator. And this allows then our customers to do scheduled machinery plant downtimes, which normally would be, so in a traditional way, you would schedule a plant downtime once a year or twice a year, and then you would take all the machinery apart. Whereas with a predictive maintenance in place, your drive warns you when the next maintenance schedule is needed. So you can do this closer to a breakdown or prolong that period of usage instead of taking it apart while you probably don't have to do that at the moment. So that means customers reach a longer service life of components and of their machinery, and you reduce the service and the material costs. Here's an example for a setup. So how we use smarts in a typical gearbox. So we are currently able to use vibration sensors and temperature sensors. So in our case, then that would be a PT1000 in the motor or a vibration sensor in the gearbox, and to get environmental data around the drive. And this we combine with our drive parameters and our PLC, which is integrated in the frequency inverter. And inside the PLC, we have algorithms running. And these algorithms monitor the drive constantly and calculate what we call virtual sensors. So based on that drive data, we can calculate the oil lifetime. So we, for example, if the motor is always half the load and the calculated oil temperature of the drive is, let's say, 40, 50 degrees, we know, okay, the next oil change will be probably in 30,000 hours. And this is based on our internal calculations and the know-how we have about each gearbox configuration. And this kind of knowledge then can be transferred via various bus systems to a higher level PLC, but also can be given via analog beacon to an operator nearby, or if people like to have a more sophisticated solution, we can also design a local dashboard on an HMI where an operator can pass by and check like the states of various drives in the surrounding. Since many companies, they use hundreds of drives in one workshop. This is an example how these dashboards can look like, what we have done for customers already. So you see a traditional conveyor setup, and you can then get the details for each of your conveyors. You can see a history of drive data. So you could see, for example, the utilization, the load current, the power consumption over time. And this data can be also stored in a local industrial PC. So you would have the history, you can see historic error messages, you could see what's going on in my production over a certain period of time, like what was my power consumption, for example, compared this month to last month or this year to last year. And you can see also live data of the drive displayed. What's the current temperature, what's the current load, is there any problem? And it could be then also visualized on a beacon that gives you, for example, a yellow or a red warning light if something is going wrong. It's just a more detailed view of this. So this is highly customized. So we set it up according to our customers' demands. Whatever information they want to get from the drive. And yes, so this I already described. So this currently we give three options. So one is we just collect data and transfer it to a PLC or to an industrial PC. The second option is we process these data already inside the PLC and do autonomous threshold-based decisions based on algorithms, which we develop together with our customers. And option 3 then for the full package is, okay, we also install an HMI display where the status of the drive can be viewed according to the customer's requirements. So the information the customer wants to see is then locally displayed on a HMI display. And as an additional option, so what we develop for our drives is that we calculate the oil lifetime internally for each and every drive. I will go into details a little bit later. So just to give you an example, normally in a very conservative way, gearbox manufacturers calculate the oil life according to worst case, the same as we would calculate bearing life or the overall component lifetime. And for example, for mineral oil, this is 10,000 hours, and for synthetic oil, that would be 20,000 hours. But most drives are utilized only, let's say, 30 to 60% of their designed load, and they also don't run all the time. So that means instead of worst case 10,000 hours, which we would give for mineral oil lifetime from our catalog, once we monitor this and we say, okay, you're not running 3 shifts, you're running 1 shift, and your average load is about 60%. That means we can double that lifetime. So instead of 10,000 hours, you can get 20,000 hours of mineral oil. And instead of 20,000 hours, we give you 40,000 hours max for the synthetic oil, which increases your machine service interval from probably 2 years to 4 years. And yeah, helps a lot of customers to save money because your oil is also not cheap. And these sensors, so you don't need to buy any additional hardware. This is all, we call that virtual sensors, so it's all based on an algorithm running inside of our gearbox, based on the know-how we have on the gearbox selection. This is another example which we have integrated in an international airport. So the customer asked us to have a visualization of the drive status. So they wanted to know this by for each conveyor section, and so we designed a system where we have a decentralized frequency inverter with a digital output, beacon light, and we use 2 sensors, a PT1000 and a vibration sensor. So this data then is processed internally in the inverter, and we have certain thresholds defined for current, motor temperature, and vibration levels. And then for each conveyor section, they have a local PC and a HMI dashboard to present the conveyor data. So an operator, if a beacon light turns on and gives a warning, an operator can go to that dashboard and see, okay, which drive is affected and what's the problem. So is it currently motor temperature too hot, over current, or strong vibrations? So they can start planning countermeasures before they have a breakdown. So they can say, okay, in the night shift, or the next time that conveyor is not used, we will do a planned maintenance to avoid a breakdown situation. And how we do that currently is we use an Ethernet-based bus protocol, and we use the UDP channel, which mostly is not utilized by the customer, to transfer our dashboard data to the HMI. So that means the customer has the full capacity of the Ethernet bus for other machine parts, other decisions. So so the whole system doesn't lack speed or capacity, since we internally process most of the drive data and all the drive relevant information. This is another example. So what we have done together with pump customers. In the pump industry, downtime is should be avoided, because once you have the machine down, a whole batch might get bad. So they might have to replace a whole batch of, let's say, yogurt or any other food. And what we do here is we developed an algorithm for them in the drive that's continuously monitoring the load and besides other data. So if a pump gets blocked, normally the drive would shut down with an overload failure. So to avoid that error, so once a certain threshold is reached, the pump stops and then runs backwards and tries to unblock this blockage. And it does this a certain time autonomously, unless it can't clear it. So then an operator or warning would be given to a centralized control panel. But if the drive can clear the problem itself, so that means the batch can be processed and there is no downtime. And also you reduce the amount of operators which, for example, in current condition in Victoria, where the government says, okay, you should reduce your workforce to 66%, I think, at the moment in warehouses or in other operations to avoid the spread of COVID. That means you have less operators to maintain all your equipment. So you want your equipment to basically maintain or monitor itself. Yeah. So the advantages are then to bring the system to a safe state. So the system is always first trying to clear the problem itself. And secondly, then if the problem can't be cleared, okay, operator is informed. And this allows you to reduce downtime and optimize the whole process. So, and as I said in the beginning, this is according to the customer is now very flexible. So you can have the drive only for monitoring, which is basically Industry 3.0. You can have drive monitoring and drive control. So the process control is still done in a higher PLC or in an upper system, or you do everything locally and just transfer the historic data to the PLC. And this is up to you and your system design and let's say how complicated your system design is. So we are still limited, so we don't have unlimited processing power, but if you have a simple enough process, you might want to do it in the actuator autonomously. Yes. So since this is a quite short session here, I come to the end, and we are open for questions now. Richard will help me to answer them, and please share with us. So what are your questions regarding IoT 4.0? Have you implemented already, and what kind of IoT functions are you currently utilizing, or are you planning to utilize? Thank you.
Yeah, thanks, Max. So currently we don't have any questions in the chat window, but if anyone wants to unmute and raise their hand, then they can ask a question straight away. But I'd just like to thank Max for presenting and everyone for attending. If there are no other questions, then I'd also like to remind everyone of our next session that's on the 3rd of September. In that session, I'll be showing everyone how to create a dashboard within 15 minutes in our software platform. So I think that concludes our session. I don't see any hands raised or any further questions coming through.
If you have further questions, you can always contact us. You find us on LinkedIn via IoT Group Australia. You can contact me directly or any of our other members if you have specific questions for PLCs, for sensors, for dashboards. So we have basically a specialist for every kind of need you have. Thank you.